Hey guys, my name is Kevin Carr. Today we're going to be going through Leetcode 56, merge intervals. So the problem statement states that given an array of intervals where intervals at the ith index is equal to a list or an array of start and end. So at each point, so let's say you're at index 0, you're going to have a start and end time, and return an array of non-overlapping intervals that cover all the intervals in the input. So the cool thing about this problem, we're going to be doing the solutions in Java and Python. So we'll do Java first because it's a little bit more complicated, and then Python, but the same strategy is similar. So the important thing to realize here is if you're in an interview, is to ask if the input, so the intervals right here, are already sorted. If they are, you can actually merge these these overlapping intervals in on time. If it is not, then you have to sort them yourselves. So that would actually require n log n or linear arithmetic time to actually sort those. So typically with these interval patterns, especially the merge interval, we're going to want to sort the intervals first, and it makes everything easy because if these first elements are sorted, then you know where you can kind of merge onto. So this is how this pattern is going to go. First, we're going to make sure that we have a base case or edge case where we can check if the intervals are empty or not. If they're empty, then we'll just return those intervals. So intervals.length is equal to 0. Then we're going to return 0. Then we're going to sort this array using almost something similar to Python, like a lambda. And we're just going to be comparing the first element. And we're going to be using the integer.compare of A at the 0, or the first start element, and B, that start element. Once that's sorted, then our problem becomes trivial. The only thing to mention here is in comparison to Python, we're actually going to be using a helper function to convert an array list to the outputs specified right here. So this double array, or this array of integer arrays. Why do we need to do this? Well, I wanted to use an array list because it's dynamic in size. If I were to have the output int of, or an array of arrays, I would have to specify and have it fixed. So I don't know ahead of time. So this is just the best way I see to proceed. So I'm going to create an array list and a collection of these integer arrays. I'm going to call this integers to convert. From this, we use the base array list type. So what we want to do first is we want to add the first interval as the last interval. And this becomes important when we actually compare within our future iteration. And don't worry, I'll make sure to specify that down below. But we're going to have a placeholder variable called last interval. And this is going to check if there's any overlapping parts. And this is where the sorting is also important, because once it's sorted, we can check if the start of the current interval, which you'll see in this new for loop, is in between or below the end time of the last interval. So since we have that last interval already set and added to this intervals to convert method up below in this array list, we're going to start at index 1 in order to do the appropriate comparisons. Make sure I have I less than intervals.length, I plus plus. Once we're inside this, we're going to create an array called cur interval equals intervals at the ith index. Now this is where the real meat and potatoes of this algorithm really come into place. So how do we know if we are overlapping with the current interval or the last interval? Well, we know that if the start time of the current interval is less than or equal to the end time of the last interval. So how does that look like in code? So the cur interval that start time of the current interval is less than or equal to the end time, which is denoted by the value at index 1 for last interval. If that's the case, then we want to make sure we get the min of the start times for current interval and last interval, and the maximum for the end time of current interval and last interval. Why do we want to do that? Because we want to merge these intervals and then have their boundaries be expanded to whichever is greater in the minimum and maximum direction. So how do we write that in code? So we reset the values in last interval is equal to math.min of the start times. So last interval at 0 and the current interval at 0. The same thing, except we're going to be doing max for the end times. Math.max last interval at 1. The current interval at 1. Once that's reset, we want to make sure that we set the most recent value on the array list to that new value. And we use that for the arraylist.set method. Else, we know we have a non-overlapping interval, so we want to reset last interval. So last interval is equal to the current interval, and then we want to add that to the array list. So intervals to convert dot add last interval. Once we're done with iterating through every single one of the intervals, now we want to use a helper function to convert that array list to just a strictly array of integer arrays. So I'm going to create a helper function called array list to r intervals to convert. And then I'm just going to create a simple conversion so we have the same output expected from this problem statement. And this is something you would specify with your interviewer, what exactly they want the output type to be, especially if you're using something like C++ or Java. Very helpful, and it shows the interviewer too that you're clearly listening to them and thinking about these considerations as well. So we're going to create output. Now that I know the size of this array list, I can specify this output type and the length of it. The reason I used the array list in the first place is because I didn't know the onset of the problem how big that array was going to be. So this is just a simple iteration. We're going to add it to this new output. So we have the current list is equal to r.get I, and then we just add that to the current index of output. And then we finally return that output. So this would be done in O n log n time and O n space. Let me make sure I did this right. Oh, or just return intervals, not 0. And just little spelling mistakes. Make sure that you ask your interviewer what exactly they need, and to catch errors before they catch it themselves. So you can see I have a couple errors, and I have to be careful about that if I did interviews in the future. But you can see it's the accepted answer. So this is the answer for Java. Okay, let's go to Python. This is a little bit more simpler because we don't have to do any of the particular output conversions. Yeah. So all we have to do is make sure if the length of intervals is equal to 0, return intervals. We can just sort the array. So I believe you can just do sorted intervals. And we have a key lambda. So maybe it's intervals.sort at the key. I think that's it. Intervals.sort key equals lambda x a b a 0 less than b0. Let me just make sure. We'll print the intervals to make sure that lambda is working. Don't know off the top of my head, but we'll make sure. Okay, so I'm gonna have to look at sorting lambda, Python. Okay, would be sorted. Okay, that makes sense. Okay, so I think I got this. So sorted intervals. Argument B, okay. So yeah, sometimes you don't know off the top of your head, but you gotta make sure that you have these kind of base things ready for your interviews. Yeah, okay, lambda sort. Oh, okay, so I don't even actually have to do the comparison. I just do it by the first element. So I believe this will work. So intervals equal this. Okay, cool. So now we have it sorted. We're going to create an output one. We have this. The output at 0 is going to be, or we're going to append intervals at 0. And actually, we'll have that be last interval equals intervals 0. So same thing, it's pretty simple going on here now. All we gotta do is, now that we added that, we can do for I in range starting at 1, leng intervals, cur interval equals intervals at I, if cur interval, I don't even have to do the parentheses, cur interval, that start time at index 0 is less than or equal to the last interval's end time, which is at index 1, then we are going to make sure that the last interval is reset. So for these values, we want the beginning or start time to be the lower value, so we're going to be using min. So last interval, that start time, and the current interval, that start time, whichever is lower. And then the max or the larger end time. Once that's done, we can just do the last value. So output, the leng of output minus 1 equals last interval. Else, if that's the case, you don't have an overlapping interval, so you reset the last interval. So last interval equals cur interval, and then you just add that to the output. So dot append last interval, and then you just return the output. And this is done in O(n) log n time because we sort this, and the fastest sorting algorithm is in that same time complexity. So it doesn't even matter with this iteration being in O(n) time. This sorting algorithm overshadows or overpowers it, because remember, we drop everything lower than the longest time complexity. So we'll run this. Again, little misspellings, you gotta be careful about that for your interviews. Oh, 1.6, okay. Oh, again, this little thing right here, and this should return correctly now. Yep, and that's how you solve it in Python. So you can see there's a substantially less code than in Java because of the typing and conversion issue, but this is pretty simple to read. So what do you do for a lot of these merge interval problems? First, you ask if it's already sorted, because I'll save you a lot of time complexity if it is not. And if it's not, then your time complexity is usually going to be O(n) log n time, which is linear arithmetic. Before you iterate through it, you make sure that you set a last interval on the first interval and append that to output. And then this is where the algorithm comes in. If you have a current interval, that start time that is lower than the last interval's end time, then you reset everything to the min and max start and end time, and then just reset the last interval or last interval in output. If that's not the case, then you do not have an overlapping interval, and then you can just reset this last interval, and then you reset that last interval and then append it to output. And that basically gets you a list of non-overlapping intervals. So anyways, guys, thanks for joining, and I'll see you guys in the next video. Cheers.